要不我从我这边来播吧，你稍等一下啊，请大家稍等一下，或等我来播
嗯，
吧，
小
没事，我来播。I'll be talking today a lot around the AirPods Pro, but in the wider context, we're looking at them as an example of a change that's happening in the hearing technology landscape. And we're seeing it drive to improve access and affordability of hearing technologies with a lot of new products recently coming on the market. Now, I'm particularly interested in apps and devices to help people hear and communicate better. So when the new hearing features were introduced for the Apple AirPods Pro, I was really keen to explore them. So here I'm going to share some of the most interesting insights and learning. So first up, what are the hearing features available in Apple AirPods Pro? How to set them up and personalize them as hearing devices? We're then going to look at the performance characteristics and go through some capabilities and limitations. So what are the hearing features available in AirPods Pro? Now, most people who own AirPods Pro probably bought them as a nicely designed earphone with good quality audio. Integrates well with their phone. They probably don't realize that they also contain some really useful hearing features. So here are some that I think are quite useful. Firstly, there's Live Listen. Now, this has been around a while, since 2014, and that's when you can use your iPhone as a remote microphone. Then you place it closer to the person speaking, and it streams the amplified audio direct to your AirPods or your compatible hearing aids. And it's really useful in a noisy environment, or if you're listening from across the room. Now, the AirPods Pro also have 3 noise control modes. There's active noise cancellation. So apart from the obvious benefit where you can cancel out annoying sounds, you can also listen to, for example, your music or podcast in a noisy environment without having to turn the volume level up really loud. So you can maintain safer listening levels. The other really interesting one here is transparency mode, and that's when you can let the outside sound in and be more aware of what's happening around you. The next one is background sounds. This has recently come in. You can listen and play calming sounds like a stream or the sound of rain, and this can help alleviate tinnitus. And then the last two, what we're really interested in for this talk, headphone accommodations. You can customize your headphones to your hearing needs and individual preferences, so you can hear sound clearer, and also conversation boost. And this is to help hearing better in noise. So to delve into those last two a bit further, headphone accommodations, it was released in iOS 14, so like 2020. What it does is it amplifies the sounds based on the user's hearing needs. And there's a few different ways where you can set this up. You can use an audiogram, which is going to give you the most personalized sound, or you can do quick A/B listening comparisons. You can hear different versions of speech or music and choose the one you prefer, and the system will choose the appropriate preset profile. So they have 3 preset profiles called balance tone, vocal range, or brightness, and they can be applied at 3 different strengths. Now, a really good benefit of the headphone accommodations is that there's no Bluetooth delay in the processed audio. And if you've used some hearing amplification apps, you may have noticed a delay or echo that affects the listening experience. With the AirPods Pro, they do the audio processing in the H1 chip, in the AirPod in the ear, so you don't get that delay from relaying the audio from the phone to the earphone. And headphone accommodations can be applied to phone calls, media, and to the sounds around you. That last one, of course, making AirPods more like hearables. Now, the next one, Conversation Boost. This was released with iOS 15, so just towards the end of last year. It aims to help improve communication in noisy environments. So we know that hearing impaired people have increased difficulty understanding speech and background noise. We can think of this as sort of like a directional mode. So in the Apple terms, it uses computational audio and beamforming to focus on the person speaking in front. At the same time, it's attenuating sounds around the listener to the background noise. So it's these two features, headphone accommodations and conversation boost, that we're most interested in when we're comparing the AirPods to hearing aids. So now we're familiar with the main hearing features. How do we set them up and personalize AirPods Pro as hearing devices? Now, it's not as easy as one might expect. It's actually, these features are buried in layers of menus, and setup can be a bit tricky. So this next part of the talk is a kind of tutorial, but rather than rehash some of the instruction guides that are out there, I'm going to focus specifically on how to tune headphone accommodations using an audiogram, and also share some helpful tips. Okay, so setting up headphone accommodations, you go to the settings menu, tap on accessibility. Then you want to scroll down and find the section about hearing. So here is hearing, you tap on audio visual, and then go to headphone accommodations. You want to switch headphone accommodations on, and then go to custom audio setup. Now, this recording will be available after the event, so if you don't capture everything now, you can check back later. So then we want to add a custom audiogram. So we go to add audiogram, and there's a few different ways we can do this. We can use the camera to take a photograph of the audiogram. You can use a photo that you've already got stored, or you can upload a file, for example, a PDF. I'm going to go through and take a photo with the camera because that's kind of fun. In this example, I just pulled up an audiogram on my screen, on my monitor, but you could equally have one printed out on paper, and the iPhone goes directly to camera mode. You don't have to do anything. It actually automatically finds that audiogram in the camera view and takes a photo. So you don't even actually have to press that button down the bottom. And it then displays what it thinks is the audiogram. Now, I think that looks pretty good. I'm quite happy with that. You can try and retake that photo if you want. But we can move on, and then it analyzes the audiogram. And this part does require an internet connection. If you don't have internet available, you can enter the values manually. But with an internet connection, it'll go through and pull out the relevant hearing thresholds from that image. Now we see that it does pretty well, but it's not perfect. And we can scroll down if we want and look at some values that are missing and go in and enter those manually and correct any others that it may have not quite got right. Generally, I find that if there are hearing thresholds that are the same in the left and the right ear, it tends to miss one of them. But you can go through and then confirm your data. Now, one thing I've noticed is that it's limited to the frequencies you see here, so 125 Hertz up to 8 kilohertz in octave steps. And there doesn't seem to be a way to input any other frequencies that you might have. The next step is then to listen to audio samples with the recommended settings. So that's using this audiogram that you've just put in. and you can go through and listen to it, switch between the customized audio or the standard, and choose the one you like. So if it's all working well, the one that uses the audiogram should sound better to you. So that's the setting up with the headphone accommodations to the audiogram. What I also recommend is to do an ear tip fit. And what this will do is just check that the ear tips, you've got the right size, they're sealing in the ear canal properly, and that can really affect the sound quality. It can affect the performance of the noise reduction, and then just make things generally more comfortable. So to do this, you go to Settings and Bluetooth. You want to click on the little eye icon next to the name of your AirPods Pro and the device list, and it will bring up this menu and go to Test Ear Tip Fit. So this is the test. You want to place the AirPods in your ear, which they should be already if they're connected, and when you press play, it will play some music. Now you want it, and it will come back with a result for each ear. Now in this case, it's come back with a sort of a yellow result where it says adjust or try a different ear tip. So you just want to try wiggling it around, see if you can get a better fit. And if that doesn't, run the test again. If that doesn't work, you may want to switch to one of the different ear tip sizes. But with a good result, it comes back green, that's a good seal, and the right size will not only be more comfortable, it reduces audio leaking out, you'll get better low frequencies, and reduce that ambient noise leaking in. The second tip I have is to create a hearing shortcut in the control center. To do this, go to Settings and then Control Center. You want to look at the hearing icon is not in the included controls, so scroll down and find it, and then press the little plus icon next to hearing. Now what that will do is when you go to Control Center, it will put down the bottom this extra button with the ear on it, so that's your hearing shortcut control. And what that means is that you can then now do adjustments for headphone accommodations from the control center, and you don't have to go back into all those accessibility setting menus. So when you press on that, you can see all the AirPods options. Headphone accommodations, you want to make sure transparency is in there so that they're going to work as hearing devices. You can adjust the amplification, so that's like a volume control, the balance, which is the balance between the left and the right audio channels. Scroll down a bit further, you also have control over the tone, so whether it's more low frequency, darker, or more high frequency, which they call brighter. And you can adjust the ambient noise reduction and turn conversation boost on or off. So these parameters can be easily adjusted by the user in the situation. In the current situation, however, they feel they need extra boost or not. All right, so how are we going? We're all set up. What is the performance characteristics of AirPods Pro hearing features? So we performed electroacoustic measurements in the lab, both in quiet and in background noise. First, we wanted to determine the amount of amplification and the frequency response provided by headphone accommodation. And for these measurements, we used an ear simulator, which is widely used for standardized acoustic testing of headphones and hearing aids. And we did measurements with the speech stimulus level at 3 levels, so 50 dB-SBL, which is the soft speech level, 65 an average level, and at 80 dB-SBL, a loud level. And these are the profiles, the headphone accommodation gain for 2 preset profiles at moderate strength. So for the balanced tone profile on the left, we see that headphone accommodations gain at a level of 65 dB SPL gave a boost of about 12 dB between 2 and 5 kilohertz. And we can see the compression, there's more amplification for the soft sounds than there is for the loud sounds. On the right, for the brightness preset, there's more boost in the high frequencies with a 15 dB gain at 4 kilohertz at that 65 dB SPL input level. Now looking at how much gain control the user has with the quick adjustment settings, with the amplification control, they can slide it from 0 to 100%, and this gives them a 12 dB range of gain adjustment. 8:18 a.m. Oh, and with the tone control, this is a spectral tilt, which pivots around about 1.5 kilohertz, and going from 0%, which is the darker setting, to 100% brighter, the user can increase amplification of the high frequencies by 8 dB while simultaneously decreasing the low frequencies by up to 4 dB. Now, if we want to look at how much gain can get a better fitting of, if we want to get a better understanding of what the fitting algorithm is in the AirPods Pro, we can look at inputting a custom audiogram and measuring the output levels. So here are two custom audiograms we've looked at. We've got one with a mild to moderate sloping loss from 20 to 50 dBHL and a flat 40 dB loss. And we want to know how headphone accommodation gains compares to a typical hearing aid prescription. So we can see here again the headphone accommodations gain with the solid lines at 50, 65 and 80 dB SPL speech levels, and we compare that to the NAL NL2 prescription for the insertion gain, which is shown by the dotted lines. And we can see a really close match in the red, which is the average speech levels, but there's greater amplification with headphone accommodation, so in the yellow at loud speech levels, and lower amplification with headphone accommodation at soft speech levels. A similar result for the flat 40 dBHL audiogram, greater amplification at loud levels and lower amplification at soft levels. So we can expect there to be differences for the AirPods Pro compared to hearing aids that have been programmed to meet NAL and NL2 targets in the audibility of soft sounds and for loudness comfort. Our next phase was to look at how AirPods Pro perform in background noise. So shown here is one of our acoustic test rooms with a circular array of loudspeakers. We have a person sitting on that chair in the middle wearing AirPods Pro. We put probe tube microphones in their ear to measure the level near the eardrum. There's multi-talk babble noise coming out from the speakers at a level of 65 dB SPL, and we use a signal-to-noise ratio of -3 dB, which is quite a challenging or common signal-to-noise ratio experienced, for example, in restaurants. And then we use the phase inversion method to calculate the signal-to-noise ratio. I won't go into too much detail, but basically we play two successive recordings, one with the phase of the speech signal inverted, and then when we subtract those signals, we can extract the speech. When we add them, we can extract the noise and then calculate the signal-to-noise ratio. So looking at the effect of these new features, so there's conversation boost and ambient noise reduction. We calculated the difference in the signal-to-noise ratio between using headphone accommodations with these features compared to with these features turned on, that is, compared to when they're turned off. And then to relate that SNR advantage to speech intelligibility, we applied band important weights that were based on the Speech Intelligibility Index. So for this arrangement, with noise coming from 5 speakers located to the side and the rear, there was about a 4.5 to 5.5 dB advantage due to conversation boost beamforming. And this correlates to the directionality in hearing aids, which increases speech intelligibility. There was also around about a 2 dB advantage due to ambient noise reduction, and noise reduction generally improves listening comfort. So we saw there were slight differences between hearing loss profiles. Generally, milder hearing losses with less amplification showed less SNR advantage due to conversation boost. With a second, more challenging arrangement with noise coming from all directions, and out of all 16 speakers, these measurements were repeated. This time we've got a near normal audiogram in the hearing profile to match participants that we had in a study that was running in parallel with AirPods Pro. And compared to the unaided condition, we see the SII weighted SNR advantage overall of 5.3 dB, but 3.2 when we're looking at just the conversation boost feature. And this can be compared to hearing aids with conventional directional microphones that provide a 3 to 6 dB SNR improvement in diffuse noise. All right, so just quickly referencing to a study that was run by Joaquin Valderrama, Venezuela, where we were evaluating the benefits of AirPods Pro with normal hearing participants that had self-reported hearing and noise difficulties. And just on one of the results from that study, the speech and noise testing that was done with the same arrangement that we just showed, that arrangement 2 with the noise diffuse around the listener, the AirPods Pro provided a 12% increase in speech intelligibility compared to the unaided condition. And on subjective ratings, they said with the AirPods Pro, it was less mentally demanding, it improved performance and required less effort. So just the last section, what are the capabilities and limitations of AirPods Pro? I've mentioned quite a few of these already. So the capabilities, improved audibility of sound, improved SNR, and reduced background noise. Other things to consider, the lower cost than hearing aids, reduced stigma. Some people don't like the look of traditional hearing aids. They have that active noise cancellation mode. And another good thing is that there's frequent firmware updates, so they're constantly getting new features without you needing to do anything extra. On the limitation side, we've seen that there's a limited control over the fitting parameters. You don't have that flexibility to adjust the fitting like you do with hearing aid fitting software. The gain at the soft and the loud levels differs from some hearing aid prescriptions. I didn't mention previously, you can't set up the left and right ears separately. So the same profile actually gets used for both ears. So that may be an issue if someone has an asymmetrical hearing loss. They also lack some advanced features of hearing aids, and they're more for situational use, not for all-day wear because of the battery life and some comfort issues. So to close off, as an overall summary, the AirPods Pro now include features that give them hearing aid-like functionality. Setting up the AirPods requires a number of steps and know-how to get the most out of these devices and tune them to individual needs. And I hope that the steps earlier can help with that. Our acoustic measures show that AirPods Pro provide frequency and level-dependent amplification and improve the SNR in noisy environments. And while they do have limitations, they may be a good low-cost situational use option for people with hearing difficulties that are not ready for hearing aids. So that brings us to a close. Thanks for listening. I'd also like to thank my colleagues who have contributed to this work. So Jorge Mejia, Joaquin Valderrama Valenzuela, and Brent Edwards.
好的，非常感谢我们刚才是 Nicky 给我们做的关于这个 AirPods Pro 的一些介绍。那就像我们刚才说的，由于这个时差的问题，所以我们今天本来原定的这个 Jorge 尼西亚的这一个 Q&A 环节的话，他没有办法在线参与。但是因为我们知道那个阅文的林凯这边，他们其实产品也是基于这个通用芯片做了一些开发。那么，所以我们请林凯先上线下来跟我们先讲一下，就是看看你刚才我们听了这个 Nicky 的这边的演讲之后，你有没有一些什么总结或者想要说的话？来，林凯，把时间交给你。Hello，林 ，OK，好的，
哎，Hello，你能听到吗？
哎，可以，好，你说，
啊，好的，对，刚才那个也听那个呃关于 AirPods 的这个 AirPods Pro 的这个一个 study，我觉得还是很有意思的，就是前面先讲了那个 AirPods Pro 怎么样去 set up 一个 AirPods Pro as a hearing aid，然后作为助听器怎么样去使用，然后后面还也讲到了，就是还做了很多详细的一些测试吧，对 AirPods Pro 作为助听器的一个性能、它的频响、它的补偿，还有它的一些优缺点，我觉得还是非常非常系统性的一个测试的，这个是我们之前也非常感兴趣的一个测试吧，因为 AirPods Pro 当时出了那个关于辅听的一些功能之后，很多人就对它的，比如说它的临床性、它的实际的可用性是什么样子的，还是有很多好奇的。所以，然后 NAL 我觉得作为一个我觉得目前应该是在听力学界相当权威的一个机构去做这样的一个评测，还是非常有权威性和说服力的。最后还包括像讲评响，最后还讲到了总结了很多，像 AirPods Pro 它现在在用于一些有听损的人士，能够提升他们的那个言语识别度，能够减轻他们的那个listening effort，就是减轻他们的听力的负担，应该是算。但同时也有很多的 limitation 吧，有很多的限制。对于 AirPods Pro，它的比如说使用时间不够长，它的一些可能经典的一些助听器有的功能，像波束形成呀，像一些左右的控制，刚才也讲的非常的详细，我觉得还是非常有收获的一个分享。
好的，谢谢。他其实也说到了一些 AirPod 的一些小的一些缺点吧，就是刚才说，就是有些助听器的功能它并没有很全面。但我还是印象最深刻的是他说到一个解决这一个刻板印象的问题，因为这个我们在第一期的那个 Andy 的分享的时候也是提到了这个问题，就是他根据他的理解跟观察看到，就好像可能很多尤其是轻中度的用户其实不接受助听器的原因还是刻板印象。就觉得这个产品就叫助听器，可能就是属于残障的人士才去使用的。那所以这也是为什么我觉得 AirPods Pro 出来之后，可能我觉得至少对于听力行业带来了蛮多的一些影响跟改变的。那包括有一些用户的话，也会去考虑到说，哎，那我是不是可以试看看用这种方式来去佩戴？因为我记得上次在那个有香港大他们有一个分享的时候也提到这一点，说他们在 Space Saver 的时候，就是有一些用户过来那个想要就是测一下听力，然后配助听器。那如果就是说用户的这个听力的损失情况其实没有很严重，他可能叫有听力困难，就还没有到我们所谓达到那个听力损失的程度的情况下，他们有的验配是就是听力学家会建议用户说，要不你回去买一个 AirPods Pro 先听一下，先试看看它的情况怎么样。那如果觉得 OK，我们再来看看要不要尝试其他的方案。所以我觉得好像它也变成了一种补充的这种一种感觉。OK，好的。 那林凯，我这边有个小问题想要跟你互动。我们想先说一下，如果小伙伴有问题的话，还是可以继续在留言区那个提问，因为我们刚才已经跟NAL 的小伙伴已经沟通了一下，就是说如果我们有任何疑问的话，可以留言。那后面我们会把这些问题全部是统一发给他们去邮件回复。那后面我们会在我们的公众号这边公众号文章在誊写的时候会把这个所有的问题跟答案写在上面，所以大家还是可以继续提问的，这个没有问题的。OK。好的，那林凯这边我有想问一下你哈，因为苹果相当于是属于一个通用芯片的，但它也不算很标准的通用芯片，就是它对于这种就是说非我们 DSP 的这种芯片，那它上面去做一些助听的这些功能。那么因为我知道其实 Ben 之前在接受 CNN Review 的采访的时候也说到了这个通用芯片上面做一些助听算法的，他也做了一些解释。那我其实想问的问题就是说。通用芯片上面的这种开发，到底对于开发者，尤其对于一个助听器的制造商而言来说，是不是一个很巨大的挑战？就是说，还是说相对于 DSP 这种来说，其实挑战也还好。那就是说，如果后面要实现的难度大吗？我们就想关心一下这个点，实现上面。
我觉得可能我们刚开始2018年刚开始做的时候，当时还是有比较大的难度的，因为助听器现在那个专用的芯片发展了这么多年，它的很多算法已经相当成熟了，而且确实我觉得从就是各方面全局最优化的一个角度来说，把算法做成一个硬件的模块，然后直接用硬件通路去跑，这个确实是最优的一个方案。所以我们刚开始做的时候，虽然是用通用芯片，我们看到可能在未来的这一个发展趋势里面，通用芯片的算力可能马上会上来，它的比如说芯片的制程节点会更新的很快，可能在未来的某一个时间会实现一个爆发性的一个增长了。比如说我可能用消耗相同的功耗，能够达到10倍、100倍甚至更多的一个算力的一个状态，但是目前还是我觉得过去的这几年我们看到是越来越接近这个趋势的，但是目前还是也是有难度我们相当于其实我们做的很多工作是要不光是把过去他们助听器的算法里面很多已有的一些算法，要通过代码、通过软件优化的形式去能够把功耗做得跟目前硬件上面跑相接近然后还要想尝试自己做一些新的算法上去像最近可能十几年非常火的人工智能做语音处理，把这个整个的模块网络加载上去，做一些新的东西，我觉得也是非常非常有挑战的一件事情。我目前看到回过头来看的话，我觉得是在我们预计的一个趋势上面，就两者的可能，比如说功耗算力的差距，确实是在越来越小，而且这个速度也非常的快但我觉得可能我们希望是在可能接下来的，比如说1到2年就能看到一个就是一个交叉点吧，就真的能够用通用芯片能够做到传统的助听器专用芯片能够做到的一个效果，甚至也还要比他们更好一些那我相信就当达到这个交叉点之后随着后面它的那个差距就会明显的越来越大，越来越拉开。
对，这些你解释的非常的完整跟清楚，因为这也是因为我也有参观过你们办公室嘛，然后也看过笨的一些演讲，包括新可一些演讲，所以就包括你们之前在第三季还是第四季的时候分享了一个你们做一个那个用一个是神经网络还是什么，跑了一个那个听力图的那个识别，其实就说明还是有很多新的好玩的技术的话，可能还是要基于通用芯片去跑，可以实现自己想要做的更多的事情。所以这个确实会是一个未来可能是一个大趋势的一个方向。好的，非常谢谢林凯在这个环节给我们做的这一些解释跟分享那么所以OK，你看王和这边，我的王和他也说到，如果通用芯片可以达到同样的效果，那么消费级耳机和 OTC 助听器会融合成一个品类吗？这个林凯，你有没有一些什么理解呢？
这个也是谢谢这位那个听众的问题吧。这个是一个非常有意思的问题，我们自己也一直在关注这个趋势。 我们现在是觉得，像因为 OTC 助听器它覆盖的主要是轻中度听损的一个人群嘛。那像比如说 AirPods Pro 刚才分享的也是 AirPods Pro 它的补偿大概是在15到20 dB 左右的一个状态，这个基本上也是覆盖的是轻中度听损的一个人群。所以我们现在看下来，其实是有一定的机会的，有一定的机会。我们是觉得 hearables 和 hearing aids 是在一个融合的一个趋势上面那至于它具体融合的这个速度有多快我觉得可能也不光会取决于通用芯片迭代的速度，还会取决于包括像那个一些元器件，比如说像动铁、像麦克风这些元器件的一些更新的速度，比如说像我们现在动铁其实还是消费级跟医疗级的动铁差的还是比较大的，就整个医疗级的整个的寿命和耐用性还是会明显的要更好，所以它也是我们看是觉得是整个产业链是在一个慢慢融合的一个趋势。当然，通用芯片可能是其中非常关键的一环，甚至是最关键的一环吧。然后当然我们现在我们目前可能比较专注的是是更可能听损更严重的，就是更专业级助听器的那一块。如果通用芯片，然后我们现在也看到这样的一个趋势，就是通用芯片的算力其实逐渐也甚至能够覆盖到专业芯片和专业助听器的这样的一个品类吧。
对，这个观点其实我也是蛮认同，就是看久了之后会觉得有可能 hearable 这跟 OTC 就是有可能 hearable 会干了 OTC 的活，会有种感觉。那专业的还是更专业，因为还是有很多特殊的一些听力损失，包括一些听力需求，包括用户自己本身可能会有一些就是所谓像心理声学这方面一些需求的话，那你是需要一些专业的服务来去支撑它跟实现它。只是专业服务，比如说我们可以通过用远程的方式那然后基于通用芯片去跑。我觉得这个可能就是在模式上面，我个人也会蛮赞同你的这么一个观点。OK， 好的，那